When we divide polynomials, sometimes we get a remainder and sometimes we don't. What does that mean? I'll tell you next. Welcome to Math Bytes, I'm Allison, and today we're talking about the remainder and factor theorems. So let's jump right in. The remainder theorem says that if a polynomial p of x is divided by x minus c, then the remainder equals p of c. Okay, so let's use our example from our dividing polynomials video. In that video, we found that x cubed plus 3x squared plus 4x minus 11 divided by x minus 2 is equal to x squared plus 5x plus 14 plus 17 over x minus 2. Okay, so in this case, x minus c is x minus 2. That means that c is equal to 2. Now, it's important to remember that the general form is x minus c, so c will have the opposite sign. Okay, and in our case, p of x is equal to x cubed plus 3x squared plus 4x minus 11. So, according to our theorem, p of c is equal to the remainder. That means in our case, p of 2 should equal 17. Let's see if it does. So p of c is equal to p of 2 in this case, and plugging in, we get 2 cubed plus 3 times 2 squared plus 4 times 2 minus 11. That gives us 8 plus 12 plus 8 minus 11. 8 plus 12 is 20, so we have 20 plus 8 minus 11. That's 28 minus 11, which is 17. So we can use this theorem to determine our remainder. Now, we just learned that we can use the remainder theorem to find the remainder of polynomial division. What does a remainder of 0 mean? Well, that is summarized in the factor theorem, which states a polynomial p of x has a factor x minus c if and only if p of c is equal to 0. That is, x minus c is a factor of p of x if and only if c is a 0 of p. Okay, so if p of c is equal to 0, then x minus c is a factor of our polynomial. So if we have a remainder of 0, then we have found a factor. So going back to our example, we have x cubed plus 3x squared plus 4x minus 11 divided by x minus 2 yielded a remainder of 17. That tells us that 2 is not a 0 of this polynomial, and therefore x minus 2 is not a factor. The remainder and factor theorems help us to see how zeros of polynomials indicate factors, and that can really help when you're using polynomial division to try to factor higher degree polynomials. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if there's something you'd like to ask us, just send us an email. We're at contactmathbytes@gmail.com, and we'll see you next time.